First thing is, the sand's not green, it's sand coloured. The green bit refers to the moisture content of the sand. This sand's been used quite a lot, and a lot of the water has burnt out of it. The moisture content is very critical. Not enough water, and the sand won't bond together. Too much water, when you come to pour the metal, it'll flash into steam, and basically the mould can explode in your face. There's about 200 kilograms of sand in this box, and this one bottle of water is enough to take it from being too dry to being just about right. As you can see here, you squeeze the sand, it breaks nice and clean, and the sand shouldn't stick to your hand. Nice clean break, loads of detail where the fingerprints are, and the sand should just brush straight off. That's just nice. The mould we're going to make is for a model steam engine cylinder. It's quite a big cylinder. It's going to be cast in bronze. It's a two-part split pattern with a central core. There's some wonderful phrases involved in casting. The actual moulding box is called a flask. It comes in two parts, the cope and drag. The cope's the top and the drag's the bottom. Here we can see the pattern has been put in the drag part or the bottom of the box. It's been dusted with parting powder to stop the sand from sticking to the pattern. The first layer of sand is put through a riddle. You can see it's rubbed through, and what we've got here is pieces of bronze and aluminium that have come from previous casts. The moulding box is then filled with unsifted sand and rammed down. The ramming is very important. You can have it too hard or not hard enough. The sand I'm using here is proper moulding sand. It has bentonite clay in it to help it bond together. People use different sorts of sand, but basically proper sand's cheap enough and it's easy enough to get a hold of. It would appear that I'm hitting the sand fairly hard. Well, I am, but it's a very lightweight rammer with a big head on. The sand is not compacted as hard as it would appear. Once the box is full, it's scraped flat. In this case I'm using a piece of angle iron. The correct phrase is to strickle it with a strickling iron. This setup I've got here now with a moulding bench, it's absolutely brilliant. You've got a box with a sand in and a board, and you can brush the sand away back into the hole. It stops all the mess. Anybody heavy into casting, this is the way to go. This is the top half of the pattern. It's located on dowels to make sure it's aligned properly. There's the cope going into place. That's on pins as well, so that's lined up nice and accurately. And they sprinkle the parting powder. Before the cope's filled with sand, we need to put in a riser, a sprue and a gate. This is to enable the metal to get into the mould. I'm using quite a large riser as I've cast this pattern quite a few times now and had problems with shrinkage. The riser is the big one. The sprue is a smaller one. The sprue is where the metal goes in, and the riser is what they call a hot riser. You pour the metal into the sprue, it goes on a little channel and it goes into the riser. From the riser it goes through a gate into the pattern. Once the pattern fills up, the molten metal fills a riser up, and that forms a reservoir of molten metal to fill the pattern up to help prevent shrinkage. I'll also be putting on extended risers to try and get a good head of pressure above the pattern. Once again, we use the strickling iron to strickle off or scrape flat the top of the mould. This is the moment of truth, time to get the pattern out. The pattern is wrapped with a wrapping iron, in this case a centre punch and a bit of steel bar. A good knocking round side to side, you see it come loose. This helps to extract the pattern from the sand. Aye, not bad. It's come out very well. I'm pleased with that. Any loose particles of sand are blown away with the bellowers. It's pointless trying to leave them in because they will certainly ruin your casting. Now come to the co-op part of the mould. A nice wide deep gate is put in here. I've moulded this 2 or 3 times before and had problems with shrinkage, but I'm fairly confident having a gate this size, it should be okay. Once again, time for the wrapping iron. But I mean the top of my head's getting thin. Here we're putting vent holes into the co-op or top part of the mould. These are very important. We'll put one at each end where the core is to vent the core, and there's 2 protrusions on the pattern which are designed to have cylinder drain cocks in them. They are the highest part of the mould, so we'll put one through there as well. You can see the wire is pushed through all the way through, not pushed and pulled back. You take it all the way through to make sure there's no particles of sand left in the mould. Once again, blow all the bits out. If you don't blow them out, they will definitely fall into the mould as you put it together. I think this is probably one of my favourite bits. I spray the mould with a mixture of brake cleaner and powdered graphite, and plenty on. This is then set on fire, as you can see. It burns off the brake cleaner, leaving the mould coated in graphite. The heat also helps to skin dry the mould. I'm actually using a propane torch here just to make sure that the surface of the mould is nice and dry, because the sand, it wasn't wet but it certainly wasn't too dry. So I want to make sure we're getting no steam and getting this right. Here we can see the vent holes, one each end of the core prints for the core. The core has a hole right through it. Actually, sand cores baked in an oven. I will do a video to show how to make the cores. The cores put in place carefully. The top half, or cup of the mould, is put in place. I was a nerve-wracking time doing this. It's very easy to destroy quite a bit of work, as you can imagine. Several vent holes are put on top of the mould to allow the gas to escape easily.
Oh, aye.
See it?